X invested rupees 2,40,000 at an annual rate of interest of 10%. What is the amount after 3 years if compounding is done annually or semi-annually? We will first do annually because that is our normal calculation. Alright, first of all, 2,40,000 investment is made once. That means what we need to find out is the future value. Okay, so for part A, future value is equal to present value, open bracket, 1 plus r raised to the power of n. And we know that the present value is 2,40,000. We know that the rate of interest is 10%. And remember, 10% means 10 upon 100, which is equal to 0.1. So 1 plus 0.1 raised to the power of 3, which then equals 2,40,000 into 1.1 to the power 3, which is equal to 2,40,000. And if you have a simple calculator, you are in a position to do the math. And keep in mind, your solution may include simply the future value interest factor. If you're not given that in the question, you need to calculate it yourself, and using this formula you can easily do it. So no need to get into looking at the table. If the table is there, great. Look, alternatively 1.1 into 1.1 equal to is to the power 2. Again I press equal to power 3. So 1.331, 2,40,000 into 1.331, which will give me the answer to part A. Okay, so I have 1.331 on my calculator into 2,40,000 gives me 3,19,440. Okay, so 3,19,440. Now, as far as part B is concerned, the formula remains more or less the same. Only thing is it is multiple compounding. So first I'll explain the concept of multiple compounding, and then we'll get into the substitution. Alright, so more or less everything remains the same. Only thing is, because it's multiple, we divide by the multiple, we divide the rate of interest by the multiple, and we multiply the number of years into the multiple. When we are saying it is semi-annually means half yearly. Okay, so we are talking about a fraction of 1 by 2. What's in the denominator? 2. So we now substitute. Okay, so the future value is equal to 2,40,000, open bracket, 1 plus 0.1 divided by 2, the whole thing raised to the power of 3, which is the number of years, n, multiplied by 2, which is the number of multiple compoundings. And now we simplify it further. Okay, so we get ourselves 2,40,000. Okay, and we have 1 plus 0.1 upon 2. So I'm going to take 0.1 upon 2, which gives me 0.05. So it's going to be 1 plus 0.05 to the power 6, which we can then continue. Okay, 2,40,000, open bracket, 1.05 to the power 6, which is equal to 2,40,000 into, and now let's do the math. Okay, so we are talking about 1.05 into 1.05, and by pressing equal to now I get square. If I press it again, I get to the power 3, 4, 5, 6. Okay, so look at the difference, 1.331 and 1.300, and it's a non-terminating decimal, so 9564. Alright, and that's a little surprising. I'm going to do this one more time. 1.05 into 1.05 to 3, 4, 5, 6. This is what happens. Now, if we write all of this down, is it really necessary? The more the number of decimals you write, the more accurate your answer is going to be. I'm going to stick to 6 decimal places just for the sake of presentation, and anyway I'm going to multiply that full number into 240, which is what you all can also do. So 1.34009564. Okay, I think that's enough for the examiner. And now I'm going to take this whole number and multiply it into 240,000 and write it up to 2 decimal places. Okay, so it's going to be 321,622.95. Because this is 3 and that is less than 5, I don't need to round up the 5 I have over here. Okay, so it's going to be 321,622.95. Right, so 3,21,622.95. I hope you found this video useful, helpful. Okay, I request you all to share it with your friends and classmates. Okay, I'm sure all of you all have WhatsApp groups. Help your friends out. I'm sure they're very worried about this paper. Thank you.